Okay, so we just entered the PhET simulation for circuit construction. What we're going to do is we're going to go ahead and click on Intro, because this is going to give us the stage, is what this is called, where we're going to be able to put some different things that we want to test. So, a couple of things I want to acquaint us with as we are working here is, first off, we got a set of tools right over here that we can pull from. So different components and things, and this list goes on for quite a bit. But you can see wire, battery, light bulb, resistor, switch, some things that we've already seen in our components. We've got some different options over here, like show current, show labels, show values. We got electrons and conventional. We have a voltmeter and an ammeter. We'll figure out what those are for in just a minute. And then we've got these two little buttons, curious buttons right here, which look like a battery versus a diagram. Okay, so what I want us to do so that we can get a little bit better acquainted with working with these circuits is to click on the diagram button. You'll see that as soon as we do that, the list of components over on the side immediately changes what it looks like. Okay, what we want to do is we want to make a very, very basic circuit. And so the way that we're going to do that is we're going to go ahead and we're going to pull out a battery first. See, all I did was click and drag my battery onto the stage. And you can see this battery has some electrons in it. If I don't want to show the electrons for right now because they're kind of confusing, I can turn that off, and you can see this looks actually exactly like a battery should look in a circuit diagram. This one little terminal here and this other terminal here. If you wanted to rotate your battery, which we do, you can click and hold on one of the red circles, and that allows you to move the battery around and to rotate it however you need. Well, we're just going to make ours go vertically like this. Very good. All right, so this isn't a circuit because we know that a circuit, based off of our research, is actually a conductive path that goes all the way around from one end of a battery or a voltage source all the way back. It has to make one complete loop at least to be considered a circuit. So we need to use some wire or some other components to make ourselves a complete loop. All right, so we're going to take a wire. We're going to drag that out onto our stage as well. And I like to have just a little bit more space when I'm working with this. So I like to do, well, let me explain what I just did. So you notice that I took my little circle here and I moved it into the other circle down there, and all of a sudden it popped and turned gray. What that allowed me to do was to connect those two pieces. So that's how we're going to do connection. So what I'm going to do is I'm going to grab some wires, drag them out onto the stage, connect them like I just showed you, and then I'm going to come over. I'm just trying to make a little leg up here into which I can throw in maybe a resistor. So let's throw a resistor in here. Now you notice I popped that in there, just got the red pieces to mate up, and it automatically pops into place. Well, cool. All right, so I'm going to add a little bit more wire. So I'm getting a little bit more experience here. I'm going to keep adding some wires, and I just want to make a dog leg all the way around to finish up this circuit. Now you can build yours however you want, but what I really want to see right now is I want to have a battery, I want to have some wire that connects everything, and I want to have a resistor somewhere there in the middle of this circuit. And that's really all we need to make this circuit work. Okay, so we can show current at this point, and now you'll see when I bring those electrons back up, or I use the conventional method of showing those currents, these little blue charges are now moving from one side of the battery to the other through the resistor itself. So, okay, we have some questions. We want to be able to answer some things about what is happening in this circuit. Well, that's what our values up here are for. So they allow us to see the different values that are on different components within the circuit. For example, this battery. This battery has a electric potential of 9 volts. That's how much pressure the electrons have forcing them through the circuit. So we can click on that component, and we can change that value to whatever we want. And watch what happens as we increase the voltage. So I can step it up piece by piece, or I can slide it up. You'll notice as the pressure, the electronic potential increases, those electrons shoot through that circuit faster and faster. There's more current flowing through essentially the pipe, the wire itself, as a result of me increasing this voltage, which may or may not be one of the questions that you need to resolve. So let me set that back down to its original value, which was 9. So you can see our electrons are now back at a normal flow. There's also a resistor up at the top, which has a value. That resistance is ohms. We can increase or we can decrease that resistance. So if I decrease the resistance, watch what happens to the electrons. I can decrease and decrease and decrease and decrease, and at some point, if I decrease it enough, oh my God, everything just caught on fire. Why did the battery catch on fire? Well, the reason why, if you've ever done this at home, if you've taken a wire and gone across the terminals of a battery, it heats up really quickly because electrons, as they are moving, they heat things up. And look at how fast and how many of these electrons are moving through all of this wire. This wire would actually be very hot. And the battery itself has some internal resistance as well. And so as those electrons are moving through that battery, they heat it up as well. The only way we can get this to stop being really hot and being on fire is to add some resistance. So that resistor is very important at regulating the flow and the speed of those electrons around the circuit. It's kind of like a speed limiter. Okay? If we increase the resistance, look at what happens to the electrons. Now they're going like grandma down the road. They're going real slow. But if we decrease the resistance, the opposite happens, and those electrons go much faster. Okay, so it's telling us a couple of things about how this circuit is working. Now there are other components that we can add in. There are other tools that we can use to make some suppositions or get some information about the circuit itself. For example, I could pull the voltmeter down. And the way the voltmeter works is it's got a black probe, it's got a red probe. Black means negative, red means positive. So you can see that my electrons are flowing in one direction. I'm just going to put this probe on one side of the battery. It's got no reading because there's no current flowing through the probe. But if I put the probe on the other side of the battery, all of a sudden now it's telling me the voltage that's flowing through this circuit. Strangely enough, it's 9 volts because the battery is also 9 volts. I wonder what happens if I change the voltage of the battery. Well, look at that. It matches with all the voltage that's flowing through the circuit. Interesting. Let's put that back down to a value of, let's say, 12 volts, just to make it easy. Okay. If I move the probe, though, the red probe, let's see if anything changes. Okay, here's no difference. Here's no difference. Let me put it on the other side of the resistor, and what the heck just happened? All of a sudden, as soon as I put my red probe on the opposite side of the resistor, there's 0 voltage. Why? That is so weird. Well, maybe if I put my black probe over here, what the heck? Negative 12? Why is it 0 when I put that there, 12 when I put that there, but then if I... Oh my gosh, this is weird, isn't it? What is happening? Well, what you're observing is something called a voltage drop. Every component has some resistance, and so every component will suck up some of the pressure of the electrons moving down through this circuit. That's how it slows things down. How it acts like a speed bump is that it's sucking up some of the energy or the speed of those electrons, causing the pressure to drop. So what we're registering when we put these probes in these 2 different locations is the drop in pressure across that component. So what this is saying when I put the red here and the black here is that the pressure, the voltage, dropped 12 volts across that component, which also means that over the entire circuit, because there are no other components across this circuit, we are assuming that the wire has no resistance, the voltage drop is also 12, which directly matches up with the total pressure that the battery can provide in the first place. Okay, if I increase the resistance on the resistor, what happens to that voltage drop? Well, let's look. Go ahead and click on the resistor. change the resistance, and look, nothing happened to the voltage. Nothing happened to the drop in voltage, but we can see that our electrons are moving slower. So the drop in voltage across the circuit is always going to be equal to the battery's voltage overall. Resistors will eat up as much of the pressure as they possibly can. If I were to add more resistors, things might get a little bit hinky. We'll look at that a little bit later. We just want to get accustomed to making some measurements. So the voltage meter, again, works by putting a probe on one side of a component and a probe on the other side of the component. If we don't have both sides of the probe engaged, we're going to get no reading. And it depends on which side. The polarity is important. If I put the probe on the wrong side, I'll get the negative reading. So in most cases, I want you to just look at the numbers. Don't worry so much because you're not good enough with this yet to understand what that negative and positive means. That's fine. If you put the two probes across, say, for example, a component like a resistor, if it's a positive or a negative, you know that the resistor is causing a drop that is equal to whatever this reads out. This is a unique case. I'm telling you, in the future, you're not going to see that this voltage drop, if you have multiple components, is going to be exactly the same as the battery. There's some other things that might also occur. All right, so we have one other tool at our disposal. We have what's called an ammeter. It measures the current, because remember, current is in amps. So if I take the ammeter, it doesn't have two probes like the voltmeter does. It has one probe. And if I put that probe any point on the circuit, it's going to give me the amps, the amount of electrons flowing through that piece of that circuit at any given time. So I put it on any different part of this circuit, and what you're seeing is it all looks like right now with the setup that I've got, 12-volt battery and 9 ohm resistor, that I'm at a current value of 1.33 amps. Okay. So that means on all points on this particular circuit, the current is the same. The flow through the circuit is exactly the same. And that jives with what we're seeing. All of these electrons are marching through at the same speed. In no different piece do we see them going slower or faster. So that jives. That makes sense. Okay, well, what happens if we increase the voltage of the battery? What do we expect to happen to how fast and how many of those electrons are moving through the circuit? Well, let's see. As we increase voltage, look at the current meter. It is going up and up and up as voltage goes up. Likewise, as voltage on the battery goes down, current also goes down. They're not the same value, but they are related. As voltage goes up, current goes up. That is a clear relationship. As voltage goes up, current goes up. Okay? Okay, so let's just set this battery value back down to 12. Let's see what we get. We still have our resistor over here at 9 ohms. So we've seen as we modify how much voltage we're putting into a circuit, it affects the current. Well, what about if we change the resistance through that circuit? So let's go back up to our resistor. It's currently at 9 ohms. Let's go high and see what happens. So as we go high, current goes down. As resistance increases, current goes down. Voltage stays the same. Current goes down. And this, again, jives with what we're seeing with these electrons. They're moving slower, which means there's less of them per second that are moving through any place on this wire. It doesn't matter where we measure. Again, it's the same. We can measure on the battery, we can measure on the wire, we can measure on the resistor. It doesn't matter. That current is the same in all locations throughout the circuit. Okay, so what happens then if we reduce it under 9? Well, we're going to see that current blow up, and as we get to 0, that current becomes, it can't show it here, but that current would essentially become an infinite number, which doesn't work, which is why the circuit catches on fire, because it's moving, literally moving electrons as fast as they can possibly move, which just physically is impossible, first off. And then secondly, will cause the whole circuit to break down because, as we've said and seen in our PowerPoints and notes, that as we're moving through any circuit, any object, any material, there is an inherent resistance in that material. And that resistance is like friction. When you rub your hands together, those electrons are rubbing past things. They're causing friction. That's causing things to heat up. And so as that resistance goes down, the current goes up, the heat in the circuit goes up, and it just breaks. Which is why it's important to have resistors in circuits. In fact, if you were to open up your charging cable for your phone, you would find that even in the cord, there is a very small resistor that's tuned just perfectly to give the right amount of current, the right amount of voltage delivered to your phone from that wall outlet. If that wasn't there, it could very well damage the circuitry in your phone because those electrons will be moving too quickly. There'll be too much current inside your phone. So again, this is just a very basic overview of some different quantities that exist within a basic circuit. And hopefully this helped you to at least set the stage to answer the questions that are within your notes, that investigatory part. I think I've probably answered quite a few of them already as we went through this together, but you now hopefully have the tools. And play around, bring a light bulb out and see what a light bulb does. See what a switch does. See what adding multiple batteries in series, one after the other, does. Play around and see what you come up with. But we use this basic circuit here and our tools provided to answer the questions from your notes.